We start recording now. Oh, you're recording. Okay, good morning, student. Okay, yeah, long time no see. It has been a while, okay, since we last have this video online class in the last semester. And then, yeah, so just to have, okay, as usual, the first day of the class, we're going to have the basic course outline go through, a little bit of our teaching plan, maybe a very, very short introduction about this topic itself. Okay, and okay, then why should I start? Okay, so what I will do is that I will share screen. Okay, so I'm sharing my screen right now. Okay, so as usual, I will go through the course outline of these subjects. Okay, I really cannot split screen. Wait, just let me try to just. Okay, close audio, give control. Wow, big challenge here. Okay, as you guys can see that we have this course outline. Okay, now for these online classes, the course outline will be still the same. The only difference is the assessment method. Okay, so there will be some slight changes on the assessment method. All right, yeah, compared to the normal classes. Now, if we look at these topics here, okay, power system protections. Now, I believe, yeah, you guys were also taking this subject called power systems, okay, to actually understand how our grid, okay, our power system actually start from generations, transmission, and distribution works, okay, to actually deliver the power direct from the source to the consumer end. And then, but in power system, we don't actually talk about protections, okay? So we just assume everything is running in the under good conditions. But in real life, fault do happen, okay? I would say that in real life, problems, okay, from the generator or generation to the load, okay, they will have what we call fault, okay, F-A-U-L-T, fault happens. And guess what? This fault happen in the daily basis, okay, in the daily, that means every day, we have fault somewhere in Malaysia, okay, it happen actually every day. If without protection, then of course, those part affected by the fault will experience what we call a blackout. All right. Now, so in this subject, we will focus on the protection, okay, to make sure that this does not happen. Okay, when fault happen, isolate them. And we can see they are actually into a CLO, okay, course learning outcome, we have 5. And this 5 CLO, okay, corresponding to actually the 5 topics, okay, we are going to go through. Now, the first one, will we investigate these domestic MCB, overload fault and RCCB, residue current protection scheme. Okay, we start off from the very end, okay, the consumer end part of protection that every one of us can actually see, okay, at our home. So throughout this course, we are going to use a lot of acronym like MCB, RCCB, because these are the common language that electrical engineers speak throughout the world. They don't speak, okay, the whole long name, all right? Like MCB, RCCB, okay, these are the very, very common, what we call acronym used in electrical engineers. And after that, we will move on to the overcurrent protection scheme. Okay, there is, let us say, we move all the way to the downstream, to the final circuit, to the consumer end. And we move up one step, okay, there will be what we call this building protections. Okay, building types of protections. And then analyze distant relay. And then the third CLO is talk about transmission protection, the transmission lines protections. And then we move on again to the next CLO. We will talk about differential protections. Now, this differential protection refer to the generator protections, the transformer protections. And then lastly is the induction motor protections. So we will cover all 5 of them, okay, in this semester. And then the PLO we are going to cover is PLO 2, which is problem analysis. Now for protection, it's very important to analyze the problem. Why fault happened? Where does it happen? So problem analysis, okay? And then of course, once you know the problem, then you will have a PLO 3 that is design, okay, of solution. Okay, what will be the solutions? What is your proposed solution? And the next one is investigation. Okay, investigation is is something like this. Where the fault happened, there's always in real life when a fault happened. Okay, if it caused fire, for example, to the premise, then the bomber or the fire department will need to do investigation to investigate what causes the fire. Okay, then let's say the investigation, like in Malaysia cases, most of the time, these fire actually happen due to electrical circuit fault, especially for very, very, very old building. So what happened is that, one day investigate, give a report, okay, to Suruhan Tenaga, okay, or TMB, then they go through problem analysis. And then of course, lastly, find a solution. So these 3 PLO, okay, are interlinked with each other, okay, in these courses. Okay, now when we come to assessment, of course, we won't follow this one. Okay, there will be a slight change, okay, of this assessment. All right, there will be a slight change of this assessment. Maybe let me just type it here. Okay, midterm will be still there. So the midterm is going to be time-based midterm. I'll give you a questions. Okay, then within maybe normal midterm, okay, is 1.5 hours. So I will double the time. Okay, it will be 3 hours. So you need to do it at home, obviously, and then submit your script to me by taking pictures, okay, and then convert into PDF and submit into CN, okay. And then we have another component of test, okay. So that is 10%. So there will be a test, same, it's a time-based, but a shorter time. okay, because simpler questions. So for the midterm and test, that will take you up to 30%. And then, as usual, we still have assignment, 30%, group assignments, okay, 3 students in a group, okay. You can have 2, but not more than 3, okay. And for final exam, okay, it's going to be 40%. And of course, this final exam is going to be open-ended, okay, like last semester power electronics. I'm going to set, in this case, it's going to be 4 questions instead of 3, okay. So which corresponding to our 5 learning outcome, okay. So 4 of them. It can be simulating, okay. They are simulating for sure, okay. There will be some simulating, what we call example. Of course, there are still some equations. Assignment also simulating based. So this is what it's going to be. Okay, we are still working on the final exam and the assignment. See how we can actually accommodate to cover all the what we call the PLO. And then the rest, okay, the course content, okay, then we will actually go through the class, okay. We're going to learn about circuit breakers, okay, types of circuit breakers. So what are they? Okay, like I say, you will learn all this acronym, okay, MCB, RCD, RCCB, RCBO, okay. And then we're going to learn about overcurrent relay protections. That is at the building levels, okay, of the what we call this building protections. And then we move on to the transmission line protections, okay. How the protection for a transmission line works. And we're going to move on to differential protections. Okay, differential protections specifically are designed for large transformer and generator. Okay, and of course, the last one will be the what we call this induction motor protections. Okay, the induction motor protections. And then, okay, textbooks. Okay, the textbook we are going to use is this one. Okay, power protections and switchgear. Okay, and okay, let me just show how these books look like. This book is from McGraw-Hill. It's a very good book for protections. Okay. Okay. Yeah, I think I need to share the whole screen. Okay. So if I go on to Google's, so we can actually, yeah. Okay. Image. Okay, these are the books. Power system protection and switchgear. Okay, yeah, there are PDF as well. You can, I'm not sure you guys are allowed to, I'm not sure. I think the library should be open now, okay, after the MCO lifted. So you can easily find this book, okay? So this will be our textbooks for this entire power system protections. Okay. It's written by quite renowned professors. This book was published in India. So most of the examples and the tutorial inside, okay, are based on India power system as examples. Okay. So for us, okay, of course, when we do power system, we have to understand the geographical difference in the regions, okay, in terms of the power system wattage levels, how they do the transmission. So along the class, I will try to give you a insight of what are the difference, okay, for all these power systems. Okay, so that will be okay. The course outline. Okay, at this point, any questions? Okay, any questions? Hello, you guys there? Okay, at least someone respond a little bit lah. Otherwise, I'm not sure who am I talking about. Okay, all right. Then we will move on to the teaching plan. Teaching plan. That's my teaching plan. Okay. Okay, teaching plan. Basically, I will try to cover every topics in the time frame of 2 weeks time. Okay. Okay. The first 2 weeks here is going to be power system protection fundamentals, and then followed by overcurrent distribution protections. Okay. This will be a very long topic, so I may need to take up to 3 weeks. And then the test should be fall at week number 5. Okay, test is going to fall at week number 5, and then of course, then you should cover, whatever I go through in this first 4 weeks. And after that, we go through the transmission protections, and then we will have a midterm. Okay, we're going to have a midterm. And then after that, we have to going to have differential protection, which will cover the generator protections, the transformer protections, and lastly will be the motor protections. And week 14, okay, will be your assignment submission date. Okay, and of course, we will have some revisions. Okay. Then that should conclude our entire semester for this course. Pretty straightforward. It's it's very direct. Oh, any questions for the whole course? Okay. Now one thing, make sure you guys install MATLAB. Make sure your MATLAB is in the function and when is the assignment released? Okay, assignment will be most probably released at week number 4. Okay, will be week number 4, and it's going to be Simulink related. So I need to cover the overcurrent relay part. So it's going to be week number 4. So for online courses, we will be very focused and emphasize on the MATLAB Simulinks. Okay, make sure you get your hands on it. Okay, and yeah, it has to be a little bit towards the open-ended. So you need to really put your hands on to actually, like for example, to model certain protection scheme. Okay, using MATLAB to just to prove the idea. Okay, in terms of calculation and mathematics part, is not as intensive as the power electronics. Okay, for this one, it's more to proving the protection concepts, right? So yeah, I'm still working on it because yeah, because of this online thing, so many things we have to try to actually adjust and to to readjust to this new norm, what we call. Okay, and then I will share screen again. Okay. Okay, let's try one thing here. Video. Okay. I try to play a short video here. Okay. Let's see. You guys can see this video or not? Is it smooth lah? I mean, will it be like lag or not? So let me just try play these videos. In the class, I used to show this video to the classes and see you can hear the voice or not. Okay. Now, oh, no voice. So you guys cannot hear the voice. No sound, clear. Oh, that is cool. How to make sure the voices go through? Okay, that I need to find out. I can't. Oh, okay. I think I can do it that way. I put my microphone through my speaker here and see you guys can see the video and hear the sound or not. I will try again. So how can you guys hear the sound? No. Oh my God. No sound. Oh, even okay. Okay, never mind. I try again. See you guys can hear the sound or Okay.
That was cool.
Okay, guys, can hear the sound or not? Did hear a bit, then no audio. Okay. Anyway, the sound I think is not so important, but of course with the sound, yeah, you will hear the impact lah, okay, of this what we call this power system failure. Okay, I want to see whether my Dell speaker system can actually do this. Okay, mix audio, microphone. Okay, I'll do explanation when yeah I show the video. Okay, because yeah I don't think I can directly transmit this what we call this audio through this Microsoft Team. Okay, now let's just go through this. Okay. This video actually show example of a small substation at the golf course. Okay, that because this is just simply because the protection system failed to operate during a fault. Okay, and then you will see what actually happens. So it's very important, okay, as electrical engineer that, to ensure the protection has to be in a working condition at all time. As you can see that this is the arc fire, okay, the arc fire, okay, in the center here. Usually when the arc happen or whatever fault, your system should trip immediately. But we can see that very obvious the system does not trip, okay. So the word trips are frequently used in electrical engineers, and is a language of the electrical engineer. Trip means cut off, okay, open circuits, all right. It does not trip means it does not cut off. So that is not happen, okay, and the okay. And then of course, yeah, this is the end result. The whole thing was okay. And of course, once it blow up, that's all right. You won't see any more arc, okay. And of course, the resultant of this is explosion, and explosion lead to fire, and fire, of course, will be damaging, okay, or destroy the entire building, okay. So from this video, so I would like you guys to actually, yeah, to know the dangers, okay, or the importance of protections when this yeah, protection system fail to operate. Okay, I will show one more time. Yeah, during the explosion, right, the heat is actually very tremendous. Yeah, of course, if you see this happen, okay, get yourself as far as possible. I know curiosity is one of the humans' nature. You will say, wow, what is that? It's interesting, man, right? You will just stand there and watch, okay? So if this thing actually happens, make sure that you, yeah, you just have to get yourself, away as far as possible. And yeah, we also have some of the examples of substation. Okay. Of course, you can't hear the sound. The sound just like firecrackers. Let me just try. So these examples of the one of our local substation. Uh, yeah, even at this situation, the bomba also, people cannot go in. So you can hear the sound. It's just like firecrackers. Okay, somebody just throw, a change of firecracker inside a room lah. Okay, in the if you hear the sound, it's something like that. Okay, so you can see problem quite obvious. There are fault happening inside, and the protection system, the circuit breaker does not trip. So, and of course, it's continuing to sparks. Imagine it's just like something that in your house, you take your live wire and neutral wire, you short them together. Of course, in your house, our house circuit breaker will trip. Okay, so your house will black out. So, and then after it cut off, there's no more electricity through the live and neutral. So no matter how you short them together, nothing happened. So it just happened in a split second, pop. Okay, one sound, that's all. Okay, and if your circuit breaker does not work, okay, obviously that is what happened. Okay, when you see this video, they keep on spark, and then of course, if the upstream need to cut off lah, of course. Okay, or else the result will be what you see in the first video. The whole thing will just explode and then caught fire, and this disaster I would say. And this one is a small substation that is usually used for nearby houses and buildings. Okay. 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 Yeah. You guys can see the video clear or not? Yeah, sound, it won't transmit, but like I said, imagine, sounds like firecrackers. Okay, set mic as system audio. Wow. Okay, how? Lao Chuan Hui, set mic as audio system. How can we do that here? Wait, oh, system audio mic. Try to do a little bit of. Oh, my audio system didn't pop up. Okay, wait. I think it looks like screen recording. Okay, it capture the system sound of myself. Oh, okay. That sounds good, but yeah, we need to explore a little bit to get all these things works in the futures. Okay, never mind. I will try to explore later, but we weren't seeing video every class, right? So it's not a big issue anyway. Sound manager, audio. Okay, sound event, sound manager, audio device. Okay. Audio device, recording, microphone have, sound, communication. Default. Speaker. Headset. Seems like my Dell. Okay, more option device setting. Wow. Okay. More option. That means under control panels. Is it? Okay. Okay, more action. Okay, more action. Okay. Wow, I can't even find this thing in. It's under shape. More action. Okay. Okay. Device setting. Okay. Oh, okay. Audio. Speaker. Microphone. But I can't find the what you call this, share the camera viewpoint have. My microphone does not allow me to set that. It only have microphone, nothing else to choose. My speaker also had nothing to choose. Custom setup. Okay, I have one at least here. Oh. PC, mic, and speaker. That's all. Nothing I can choose here. Okay, I will. Yeah, maybe just unplug earphone when playing. Okay, I'll try this. I'll unplug earphone right now and try to play a video. Okay, you guys let me know you can hear the sound. Okay, can hear or not? 我烧了啊 Finally, but you guys can't hear me, right? I'm not sure my internal mic strong enough or not. Okay, sounds like yeah, PC fan sound. Okay, never mind. I'll show you guys this okay, video again.
Yeah, no sound, no sound.
Okay, guys, you all can hear the sound, right? On your end. Hello. Oh, one box sound. Oh, I have to check one more box here. No sound. Oh, okay. Come on. Why someone say can, someone say, oh, include system audio. Okay. Now we have to try one more time. Okay. Okay, let me try one more time with my Microsoft. No, sir. Oh, still no. Why some say yes, some say no. I try one more time. Okay. Share. Okay, thank you. Now I see include audio. Okay. Okay, so can oh, good. Okay, now, yeah, we have to learn along the way. Okay. So, okay, good. Now, yeah, you guys can actually experience, hear the sound so that it, and like I said, it sounds like firecrackers, okay, when these electrical fault happens. All right. So that actually indicate that as electrical engineers, sometimes it's not about, I believe by right, when you guys learn in any topic, subject, assignment and project, okay, you guys are very focused on whether your project is working or not. Okay, is it in an operating condition or not? Okay, of course that is one thing. Okay, we have to make sure it works. But along the way, okay, most of us actually won't care or don't even bother about safety. And when we don't bother whether if short circuit happen, what is my system can actually trips, okay, to avoid explosions or fire, okay, in the system. So for electrical engineers, okay, this is very, very important. That's why you guys need to study these protections. Okay, now for this class or this course, okay, some other university they may put that as an elective, but for UCSI we put it as a mandatory compulsory courses. So every one of us will actually at least have a basic ideas, okay, about these protections. Okay, so we got the sound in. Yeah, so next time when I show videos, okay, it shouldn't be any problems. And okay, what else I need to show? Okay. Okay. So one more thing. Okay. To talk about these professional engineers. Okay. Protections. Okay. To actually setting the protection relays, okay, is not everyone have the authority to do it. Okay, if we look into the Malaysia context, relays, okay, protection relay I'm referring to. Okay, maybe I just give you some idea how this protection relays looks like. Okay. This is a piece of very important equipment that as electrical engineers, okay, you must know. Okay. Okay, these are a few. Okay, current relay. Okay, now this is how it looks like. Okay, protection relay. Okay, so it's just a piece of microcontrollers that measure the current and voltage. Okay, through the system and decide. Okay, based on your setting and decide when. Okay, or under what condition that it should trip, okay, your systems. So it looks something like that. It has some form of settings. Of course, the protection in our houses, we call MCB. It looks something like that, right? In your house, okay, these are also a circuit breaker. This is circuit breakers. It's not a protection relay, okay? The difference between protection relay and circuit breaker is that circuit breaker you cannot set. Okay, when you buy in, if it is like 20 amps, it's forever 20 amps. You cannot set. Whereas for protection relays, you can set. Okay, 20 amp I don't want. I want to set maybe 40 amps. Okay, there are various settings, of course. Okay, there are various settings. So because houses are at the final circuit end, okay, at the distribution end, and before it go to the final circuits, it will go through what we call this MCB. All right, all this MCB. So for this what we call this protections relay, okay, it requires settings. So doesn't mean that everyone, okay, even when you graduate as electrical engineer, okay, you does not have the authority to do the setting. Okay, the setting, okay, require, okay, some person with what we call a competent engineers, okay, service engineer. That means, as you all guys aware that after you graduate, the first thing you need to do is to get yourself registered as the electrical engineers or professional engineers. Okay, so in Malaysia context, the professional engineer PE, okay, you were entitled to have a title IR in front of your name. Okay, that is actually good enough for you to do quite a number of consultancy work already. You know, it's almost the king in the electrical industry. However, you are still not qualified to set the relay. So to set the relay, okay, IR is still not the end. You know, you need to move one more step, 2 steps ahead. Okay, which is the service. In Malaysia context, I'm talking about, is what we call the service engineer. Okay, so service engineer, you must obtain your IR first. That's one thing, and then you have to move on to the competent engineers. Okay, and then service engineer. That's the highest you can have, and because of that reason, okay, yes, there are just a few service engineers out there, so market is big, engineers less. That means it is good business, good yeah, making money opportunity. That is where you can convert your knowledge into what we call this yeah, paycheck. Okay, and of course different country, okay, for those international students, different country have different what we call this yeah, policy regulations, on whether what types of engineers are allowed to do this and allowed to do that. Okay, so yeah, next class we'll go into detail about this, okay, in the Malaysia context, so you can gauge, okay, like, okay, how far I want to go, what is your plan. Of course, like I say, in Malaysia context, when you achieve your IR, okay, and you can actually start your own consultancy firm. That is good enough for you, to make millions of dollars already. Okay, you can see, those yeah, IR engineer usually are very rich. Okay, then imagine those with a service engineer. Those are qualified and authorized to set relay. That means they're even more richer. Okay, now, like I say, why so? Because this protection relay setting require, okay, a yearly or bi-yearly what we call this tests, okay, to be done. All right, so you just count on how many buildings we have in the whole country. Even you have to just to come to, let's say it's for UCSI, our UCSI service engineer need to come to UCSI maybe every 1 year or every 2 years. And every time you come, it charge you some amount of service charges, consultancy fees. Okay, that is in the number of 1,000. Then if this engineer, okay, let's say he have 4 buildings. I mean, of course, it will rotate, right? Every building he under his care. Okay, then just imagine he just need to work 1 day per week lah. 1 day, 1 week per building. That's in 1 month only 4 buildings you have to go. Okay, and we go for the very what we call this unrealistic charges of just 1,000 ringgit. That's in 1 month is already 4,000. Even after you retire, you can do that. There's lowest already. Of course, it depends on how complex is your building's protection systems. Okay. So yeah, usually this engineer don't have only just 4 building in a month. You know, that is how much money you can earn even after you retire. Okay, it's much more better than those, you know, on the YouTube will tell you, you know, you attend my free training, you know, I will teach you how to earn money online, stay at home, all these kind of things. Okay, I will, you know, that, I mean, be electrical engineers is much more realistic. Okay, in terms of you know, earning money in this way. And then yeah, so there's just a rough briefings, okay, for your for today classes. Okay, by the way, is there any questions? Okay, I'm going to go through the attendance once more for those who didn't say yes in the last round. And then see if they is still in the class. Okay. Okay, let me just share screen again. Okay, not share screen. I need to split this thing out so that where's the chat box? I must see the chat box here. Okay, Bella, Khalid, are you there? Bella, Khalid? No, sir. Rahul, your friend, right? Better let him know, or what happened to him? He's still in the country, right? Okay, now we move on. Ali Ayman?
Yes, sir.
You are here.
Yes.
Okay, thank you. And then Vincent Lim. Vincent Lim, are you here? Vincent Lim, not. Lee Cha-Ching. Lee Cha-Ching, are you here? So no. Okay, so we got 3 absent today. Yeah, please inform your friends. You know, I'm not sure why they didn't come today. Just make sure you know, even it's online class, you know, is important to attend as well. Doesn't mean it's online, then you have, you know, you don't need to actually attend. All right. Wait, okay. So this meeting. Okay.